For our third topic, I'm going to join Shankar Iyer to talk about Exadata High Availability. Shankar is based out of Minneapolis. This overview will cover some of the availability features that are built into Exadata, as well as some of Oracle's availability technologies that are commonly deployed with Exadata. High availability is even more important today than it was just 5 years ago. With high-density consolidations, more applications can be affected by a single system outage. There's more visibility and business impact when systems are down or underperforming. Let's look at the impact of database downtime. These are numbers that come from industry analysts, Gartner, IT Process Institute, and Forrester, and they reflect the average costs across all industries. $350,000 is the average cost of downtime per hour. 87 hours is the average amount of time a company will experience downtime each year. So if you multiply those together, that's $30 million to the bottom line simply for planned and unplanned downtime. If you happen to experience a data center outage or a disaster, it's likely to cost your company $10 million. And 91% of customers have experienced unplanned downtime over the past 24 months. Not only do customers suffer from lost revenue, which is what we're seeing here, they suffer even more from negative impact to their brand name. There are public websites dedicated to nothing more than listing each and every outage that has happened. There's sophisticated websites where you can search categories, markets, verticals to find exactly what you're looking for. No company is immune. Major cloud vendors, social media companies, banks, insurers, retail companies, telco, all of their outages are easy to come by. This is a real powerful tool that potential customers of yours can use to assess whether they would feel comfortable employing your services. So I think we can all agree that having a highly available, scalable architect impacts your company's bottom line in more ways than one. This session is all about what Oracle does to help you succeed and avoid these outages. How can we use Exadata to achieve high availability for our most critical apps? At the heart of Oracle's high availability plan is the Maximum Availability Architecture, or MAA for short. MAA starts at the top. Feeding into the design are customer insights and expert recommendations that have been collected from our huge pool of customers and community of database architects, strategists, and software developers. We've been analyzing years and years of this insight, even decades. Armed with this information, our MAA development team has deep and complete understanding of various kinds of events that can affect availability. Through this, they've developed a set of blueprints or reference architectures for what we call bronze, silver, gold, and platinum workloads. We recognize that not all workloads require the same amount of protection and that there's always a trade-off between cost, effort, and risk that must be considered. Whatever your availability goals may be, we have a recommended architecture for your reference. The MAA reference architectures use a wide array of our availability features, configuration, and operational practices to achieve the 4 goals of the MAA. So those 4 goals are listed along the right-hand side here. Continuous availability, that's the transparent failover of applications and services across systems, and that could be either between data centers or locally within a data center. Data protection, this includes things like reducing data loss through flashback technologies. It also includes the absolute data protection that you can get by using the recovery appliance, the ZDLRA. Active replication. These are technologies that allow customers to connect their applications to replicated sites that are active HA. So that would be Active Data Guard and Golden Gate technologies. And then last, the ability to scale out. The ability to scale compute nodes through RAC, real application clusters, ASM, automatic storage management, and sharding. And then along the bottom, you can see that you have a choice of various deployment options when using these reference architectures. In this session, of course, we'll be focusing on Exadata as the deployment choice. So lastly, before I turn this over to Shankar, I'll summarize a couple of key points about MAA overall. First, note that each of the 4 reference architectures, bronze, silver, gold, and platinum, build upon the previous stage. So we start with bronze. It's the simplest. It's single instance database with restart. It's suitable for development environments and maybe even some non-critical small production applications. It's the lowest cost, but it also has the longest recovery time objective. When you move then to silver, silver has in it everything that bronze does, but it adds in database HA and application continuity. And then when you move to gold, gold has everything that silver and bronze have in it, but it adds in more and so forth. So then you end up there with platinum, which is the on the right. Also notice as we move from left to right, each of the architectures provides higher availability, better recovery point objectives, and better recovery time objectives. So the risk is increasingly reduced, but the cost of implementing is increasingly more. It's important to know the business requirements for recovery point and recovery time objectives while assessing these options. And the last thing I'd like to point out is that MAA is a moving target. You need to think of it like a living document. So technology improves over time. We're constantly getting feedback from the community, and we adapt to that. The newest versions of MAA blueprints make use of the recovery appliance, which you may not have seen in copies of the blueprints before. Shankar's going to explain more about that and also lead us through the details of the technology and the levels in MAA. So Shankar, I'll hand it over to you.
Thank you, Bonnie. Like Bonnie was showing in one of the previous slides, the maximum availability architecture techniques and framework are available across multiple deployment choices, specifically to Exadata. MAA, basically, the best practices and techniques are leveraged in the entire stack of Exadata architecture, starting whether it is rack 1 or rack nodes, and provides the node level availability. In addition, ASM is now a standard building block on Exadata and provides the storage protection and redundancy, both normal as well as high redundancy. One of the other popular options that customers typically use is called Active Data Guard, and which kind of gets built on a remote data center and provides both data protection as well as query offloading capabilities. Golden Gate provides a seamless option to customers who want to manage data replication across heterogeneous databases, and also popularly used for migrating mission-critical databases with very minimal downtime. Also, RMAN and ZDLRA, or Recovery Appliance as it is called, provide feature-rich and highly consistent backup and recovery options on Exadata, and we will touch on the Recovery Appliance a little bit more in this section a little bit later. And finally, Oracle Global Data Services. It provides the service failover and load balancing capabilities that really demonstrate that on Exadata both hardware and software components work together. Let us get started with the 4 availability tiers that Bonnie had summarized. Let's start with the lowest one, the bronze application tier, which is the first layer, and it's suitable for pre-production databases or single instance production databases. The solution here includes a suitable backup either in the primary or secondary domain areas. Reviewing the outage matrix in this case, recovery from an instance failure could take minutes to hours depending on the cause of the failure. Recovery Appliance or ZDLRA in this case could play a critical role to make sure that if it is ZDLRA in this case, you can recover in near zero time. And similarly, in case of a planned outage, patching will have to be downtime there, and patching could take minutes to hours depending on whether you're deciding to patch in place or whether you're deciding to install the new version and then upgrade to that newer version. And then, of course, you can see that both the patching, there is some amount of downtime, minutes or hours, in both the planned as well as unplanned outages.
So Shankar, can I ask you a question just there for a minute? Can you flip back? There we go.
Sure.
So you're saying, like, for disaster recovery, if you were using a traditional backup solution, then you're talking about it taking hours to days, right? And then if you use the ZDRA, it becomes near zero. Is that, did I understand?
Correct. Yeah. The Recovery Appliance can help to kind of quickly come up to speed in case of a failure, even if it is a single instance, which that's what the bronze tier provides. So yeah, absolutely. I think that's one of the values the recovery appliance adds.
Okay, thanks.
So I wanted to take a quick second to review the recovery appliance details here. Recovery appliance is an engineered system solution, and it provides a complete integration with Oracle database and eliminates data loss exposure without impacting mission critical production environments. And it's not just production, it can be any database, right? So it's kind of a built-in system for possible solution for backing up Oracle database and restoring it. So what typically happens in a recovery appliance, or RA as it is called, we just send the changed blocks over to the recovery appliance after an initial instantiation. Beyond that point, the RA creates virtual full backups based on the changed blocks. At that point, we can restore the virtual backup as of any time to either remote replica or a cloud, or onto the cloud storage, or onto the tape. And there is also an enterprise manager plugin specifically for the recovery appliance, and that's used for managing and monitoring space and managing the entire process of backup and recovery. So that's kind of very valuable. A little bit more on the recovery appliance before we move on with the availability tiers here. One of the features that differentiates the recovery appliance is data protection and Oracle backup recovery validation. What happens in case of recovery appliance is the databases that we use for backing up using ZDLRA are called protected databases. And these databases could be any version starting from 12C to 19C. There are two main things I wanted to touch on. One of them is the delta push, which is basically the process that are basically transporting just the changed blocks that happen on the database over, with the causing very minimal impact to production. And for those of us who are DBA with DBA background, we know that this is very similar to kind of creating like a data guard redo ship functionality that propagates new transactions over to other side. And then the Delta Store, it provides the virtual full backup capabilities. It basically stores validated transactions, compresses them as well, and stores it on disk and handles fast recovery. And it can do up to any point using Delta. And also, the recovery appliance is part of the engineered systems family. It provides scaling and resilience as well. Let's quickly mention about what the recovery appliance can translate in terms of value to you, our customers. So using the recovery appliance can lead to dramatic database I/O and network savings, number one. And what happens is the delta push, we are not actually in this case either reading or sending duplicate blocks, so we are eliminating a lot of I/Os by doing that. We also eliminate undo blocks for committed transactions and also eliminate unused blocks as well. So that makes even more efficient the network bandwidth saving as well. Similarly, if you look at the Delta Store component, that is responsible for the backup management. We store only changed data. We don't keep multiple copies of it, saving space. We compress at block level and ship only the deltas, obviously. And in addition to improved performance, the OEM plugin that we talked about in the previous slide, it makes adding, changing, managing all those operational features much easier as well. One of the features that RA is used for is also migrating databases across multiple data centers of customers. And RA, in this case, could seamlessly handle Indian changes as well. And it kind of makes the process very repeatable so that it's much easier to migrate a lot of data from one data center to the other without having a lot of operational issues.
You could use that, though, for when you buy new hardware too, right? for migrating just from one platform in the same data.
Yeah, absolutely. I think a lot of customers use the VDR migration feature initially when they move from a traditional system to Exadata, but they may also later on use VDR for backing up those databases. But yes, absolutely. As they are adding new databases onto Exadata, they can certainly use VDR as a migration tool onto Exadata as well.
Yeah. I have another question too. I thought I had heard something about VDR doing a lot of automatic checking of the backups to make sure that they were, not corrupt and actually recoverable.
Right. Yeah, it does do that. It makes sure that if there is a backup, it makes sure that it is reliable and restorable. I think a good amount of that is also available on RMAN. If you have an RMAN backup, you also know that those files can be reliably restored.
Right. I thought the difference was that on RMAN you had to do it manually, and Recovery Appliance just automatically did it continually. Yeah.
Absolutely. Yeah. Absolutely. A lot of the RMAN capabilities are automatically available on VDR.
Yeah. Cool. Thanks.
Moving on to the Silver availability tier. Silver is one step above Bronze, and Silver is the first place where the replication cluster is introduced for production, or it's suitable for production or departmental databases. Like the rack provides availability on a node eviction, as well as the ability to load balance between nodes. Application continuity is the other thing that the Silver tier provides, and application continuity, it provides a method for seamlessly transitioning the application connections in case of loss of a node, for example. In case of Silver, the primary availability domain has the rack database along with the local backup, which could be either in the primary or secondary availability domains as well. Now, looking at the outage matrix, it takes only seconds to recover from a node failure from rack, because if a node fails, you can start it from the other node in a rack scenario. In case of a site failure, however, we will have to restore the database and from the backup and restore it. That could take a few hours or days. Again, in case of planned outage, patching can be done rolling because you can take one database down, patch it, take the other one, and then patch it, etc. So we could do a zero downtime patching for most cases. However, if you are doing database upgrades, like let's say 12C to 19C, in that case, it could take minutes to hours, again, depending on whether you are doing an in-place upgrade or you are migrating the database. Quickly wanted to touch on the application continuity because it's very critical. This is the first stage in Silver where it is introduced. Like we discussed before, application continuity is an important availability aspect to make sure the application switches appropriately in case of a node eviction. Oracle provides a whole bunch of ways to make sure the application downtime is nullified or minimized because when a node goes down, a database node goes down. Some of them are the Oracle clusterware that we know, ASM and Oracle Rack are part of it. The Fast Application Network, or FAN, it's called, is a rack feature that is integrated with what's called the Oracle Call Interface, or OCI. And FAN publishes information about changes in the cluster to applications that subscribe to FAN events. And FAN prevents unnecessary operations, basically improving time, improving availability. Things like somebody attempting to connect when servers are down, or attempting to finish processing as a transaction when the server is going down, or also waiting for TCP/IP logs. Now, there's also something called RHP helper that can be used to reduce the application blackouts or brownouts. And that can help to reduce that time from minutes to seconds for applications. The reduction is mainly because the Oracle, I mean, it's RHP reduces the impact on the sessions by actually kind of phasing out the reboot or shutdown. So the actual end time is stable, so to speak. The other one is the fleet patching and provisioning, which is a software lifecycle management method for provisioning and maintaining Oracle homes. And it incorporates some of the MAA best practices as well. I have included a couple of notes here in the slide that will give you some additional details on how to get more information on both RHP helper as well as the fleet patching and provisioning methods.
Shankar?
Yes.
What do you typically see in terms of application continuity? What do you typically see customers using? I mean, what stage are they at in that?
So the thing with application continuity, Barney, is different versions starting from 12.1, 12.2, 18 to 19. We have the application continuity features have grown. So depending on which level a customer is, they can leverage all the application continuity features in that space. So basically, they can leverage things like the JDBC features that are available with the connection pooling or draining of the service, etc. But they've gotten more and more powerful, and they are the most capable in 19C. So that's kind of why we focus on getting everybody onto 19C.
Cool. So it's just a progression, right? The more
it's
current
a progression.
you are, the more you can do.
Correct. And application continuity is a critical topic, and a lot of enhancements have been done in that area. So it's a good one to keep an eye on from the availability point of view.
Okay, thanks.
Yep. So going back to our availability tiers, the next one is gold. Barney touched on it. So in addition to bronze and silver, gold on top of that, it adds the data protection layer, and data protection can be done using Data Guard or Active Data Guard. The Active Data Guard copy of the primary database could be located either in the primary availability domain or secondary availability domain, or both, depending on how the customer wants to do it. The local backup can be configured as well. And just like we mentioned before, RA plays a good role here as well. From the outage point of view, much better than silver, because the planned outage can now be done in seconds, because we have the rack, and we also site failure can be managed as well, because just start up the database from the secondary copy. Now, the unplanned, talking about the planned, talking about the patching. Patching can be done with minimal outage as well, because rolling patches are applicable. And obviously, the database upgrade, if we had to be done, can be done with fairly minimal downtime also, because what you can do in that case is you upgrade. Maybe you can start on the DR side first, secondary availability domain side, upgrade the database, and then come back and do it on production. So without it impacting the service level. So
Shankar, I have a lot of customers that, like at a glance, it looks like it would be a gold, meaning that, you know, they have a primary data center. They do the data guard, right, to the secondary data center, right? But they're not, it's not active data guard, it's just data guard. So in that case, while if you just glanced at this picture up here, it would look to be gold, it wouldn't really be gold. Active data guard is is.
That is very true. Yeah, Active Data Guard is certainly a component of the gold, and I think that's a good segue to the next slide that I was going to show as well.
Mm-hmm.
Active Data Guard does provide some additional features over Data Guard. That's what makes it really a gold standard, so to speak.
Mm-hmm.
Let me talk about the Active Data Guard. Let me give you a quick overview.
Mm-hmm.
Active Data Guard is basically a solution for disaster recovery, right? It eliminates single point of failure by providing synchronized physical replica of the production database. It uses Oracle-aware replication to efficiently use network bandwidth and provide unique levels of data protection. So basically, what it can do over on top of the Data Guard is it can help you to fix the block corruptions, if any. When it is applying the log on the standby, if it detects a bad block, it would go and fix it seamlessly, and that's kind of what is required for availability to keep those service levels up and running. And basically, the Active Data Guard only shifts the information used by Oracle database to recover transactions, right? So it's basically the same technology. So it makes it more robust. The other good thing on Active Data Guard is the Active Data Guard database can be opened up for query-only transactions, and we see customers can do those reporting queries, etc. Thereby, they can offload processing on the production and kind of reduce some of the production load, so to speak. Mm-hmm. So that's the other feature of Active Data Guard that is helpful to customers. One of the newer features that I wanted to touch on, that is with 19C, that's called the DML redirect, and that's available on Active Data Guard. Using this feature, basically the customer can do light amount of DMLs even on the Active Data Guard, and as you can tell, light is a crucial word in this case, right? We don't want to overdo this. So what happens in this case is the user can issue a DML against the standby database or the Active Data Guard. The DML then is redirected back to the primary and then gets applied to the primary. And then as part of the redo information that is generated, that data comes through and gets applied onto the standby. So, the new DML redirect feature kind of gives some amount of features to the customer in terms of they can avoid managing another database in case they have to do some updates. So they can actually just reuse their Active Data Guard, number one, as a DR site, and number two, for doing some of the sundry light processing as well.
Mm-hmm. Nice.
So finally, the Platinum tier, which is the highest level of availability, and it is really suitable for those very critical databases that demand high time and service levels, uptime and service levels. This service basically offers the active replication, and it uses things like Golden Gate as well as addition-based replication or redefinition. Architecturally, a copy of the primary database is maintained on both primary and secondary application availability domains along with their respective backups. So recovering from a backup from a database backup happens to be in seconds and often is automatically triggered with an OEM event. So you can have an OEM event that can trigger the recovery without needing a human intervention, just to reduce the delay. Also, zero loss. Also, in case of there is a site disaster, you can just start up the other site and off you go. And then patching can be done rolling, and major upgrades can also be done with zero downtime using the Golden Gate mechanism. And then application failover can also be used for reducing the application level availability as well. But then that is different from the database level features.
So, Shankar, what is Golden Gate giving you that Active Data Guard can't?
Yeah.
Yeah.
Yeah, so that's a great question. The Active Data Guard or Data Guard is a file level or a block level storage, and it recognizes blocks and works on blocks. The Golden Gate, on the other hand, is an object level replication. So it can actually detect the changes that have happened into a table or an index or a partition. So it provides that granularity which an Oracle database needs. So you can get closer to replicating in terms of you can get to a point where you can apply these 5 updates to a table. So it gets really closer to mimicking the final state of a production database.
Okay.
So that's kind of where it plays in. It can get closer to availability than an Active Data Guard can get.
I see. Okay, thanks for that.
This slide illustrates some of the typical use cases that we often see with customers on the left-hand side. And on the right-hand side, you can see how Exadata and maximum availability architecture features can be leveraged for solving that issue. So a few examples here, looking at the double storage failure on rack, that can be solved by leveraging Data Guard, where you can maintain a standby and periodically apply the logs. If a failure happens, then you can fail over to the Data Guard database with very minimal loss of service. Similarly, managing the planned maintenance with the line of business can be fixed to a certain degree by following a rolling patch capability on Exadata. And rolling patch capability provides a way to rolling patch not only the compute, but also the storage, the database layer, the grid infrastructure, etc. Now, also Exacheck is a critical tool for ensuring all the best practices are implemented on Exadata. That's something that we recommend running every month, especially once we have a newer version of Exacheck coming out, so that customers are up to date on their best implemented. They have all the best practices implemented on Exadata. And then finally, resource consumption, things like CPU and memory, storage, I/O. It can be monitored and compared with the workload patterns on Exadata. This is something that we do very seriously on Exadata. There are tools, for example, OEM has something called Capacity Planner that keeps track of the actual utilization. And it can also help customers to, for example, move more databases in a phased approach over to Exadata once they have the main ones moved already. And finally, it's always good on Exadata to minimize customizations wherever possible, so that we can get the benefit of what I call the Exadata community effect. So every customer looks alike. With that, I'm going to turn it over to Bonnie so she can finish it off with some of the MAA benefits. Bonnie?
Thanks, Shankar. That was a lot of good information. Knowledge of the MAA blueprints really helps to assess and plan for the best architecture to suit any business. And all of the things that Exadata does automatically, the built-in MAA components and features, are critical in providing a fault-tolerant environment. And it's amazing the number of those features that are built in. I mean, you just touched on a few of the more recent ones, but the list goes on and on and on. So with Exadata MAA, you're able to achieve faster deployment, reduce the guesswork, and reduce downtime. And when you employ the ZDRA with its built-in corruption prevention, you can achieve 0 downtime. As we learned in the previous session with Oracle Enterprise Manager, you have a full suite of integrated tools and reports available. And at the end of the day, Exadata is the best platform for providing high availability, reliability, scalability, and easy management for the Oracle database. This brings us to the end of our session. I hope that you found it valuable.